Hello, today we're doing lesson 7-5. We're simplifying radical expressions. It's on page 41 and it's take 2, but I figured out why my camera quit stopping recording. I hope this is not too blurry. Here we go. So here's some vocab that you might want to know, that you might need to know. Radical expression contains a radical such as a square root. So a square root of a number is a value that when multiplied by itself gives the number. So when 7 times 7 is 49, if I do the square root of 49, the answer is 7. A number like 49 is also sometimes called a perfect square. It's a rational number with a square root that is a rational number. Recall that the square root of a positive number has two possible solutions. So a squared could be positive a times positive a or negative a times negative a, because a squared can also be negative a squared. Those two are equal. There's also something called the quotient property of square roots. I guess I'm kind of skipping that one. I'll go back to it. If I have 100, the square root of 100 divided by 4, 100 divided by 4 is 25, square root of 25 is 5. Or I can separate that 100 divided by 4 into two different square roots, find out the square root of those numbers, and then divide. Whereas with multiplication, you can multiply those two numbers, or you can separate the two numbers and find the square roots of each of them and then multiply. Okay? Example 1. We're going to simplify square roots. So, make sure I'm in the frame here. If you put this into, I don't have our calculator, I forgot it at school, but if I do the square root of 72 in the calculator, it's going to give me a big decimal. Okay, I don't want that big decimal with a problem like these. Sometimes if you know the answer is something like percent, we can do that and find the decimal. But in this case, I'm going to make something called a factor tree. So I'm going to take 72. I'm going to ignore this for now. I'm going to take 72. I'm going to factor out all the numbers. So you do need your calculator. I'm basically going to find all the prime numbers that make up the number 72. So I know 72 is an even number, so I'm going to go 72, and I'm going to click divide by 2. I'm going to leave the 36 there. I'm not going to erase it. So I divided by 2. The answer is 36. 36 is also even, so I can divide by 2 again. Divide by 2. The answer is 18. 18 is also even, so I can divide by 2 again. So I divide by 2. This time I get 9. 9 is not divisible by 2, but I know that it's divisible by 3, and that gives me the answer 3. Okay? This is gone. I'm going to ignore all these numbers. I only care about these prime numbers on the outside. Okay, it kind of makes like a little check mark or a little shoe or something. Okay, remember square root? There's an invisible 2 out there. So what I want to do here is I want to go through and I want to put my prime numbers in groups of matching 2's. So here are two numbers that match. So if I put 2 times 2 under the square root, I could take one of them out. So this is going to be a 2. It's the same as doing the square root of 2 squared. Remember, the squared and the square root would cancel out, so that would just equal 2. That's what I did here. There's no matches for this 2, but there is a match for these 3. So this one is like 3 squared, the square root of 3 squared, where the square root and the 3 in the squared cancel out, and you get just 3. So now I have a 3. This 2 times 3 is now out of the radical sign. So right now I have, let me rewrite it, I have 2 times 3, but I also still have whatever's left over that didn't get put into a pair, which is this 2 on the inside. Well, 2 times 3 is 6, and I have the square root of 2. So here, right here, is my answer. Okay? We're going to do it again. But this time, they want us to multiply. Well, doing it this way, I'm not going to multiply this times this, because then when I start doing my factor tree, I know I'm just going to take that 5 out eventually. So I'm going to write my 5 here. I don't need to factor my 5. It's in simplest form. And I'm going to remember that these are being multiplied, and I'm going to put my 48 here. I am going to factor my 48. So, your calculator. I have 48. Better over here. 48. I'm going to divide by 2 because it's even. That gives me 24. 24 is also even, so I'm going to divide by 2. I get 12. Notice I'm not clicking erase on my calculator. I'm just letting it go. The school calculators do that too. You're just going to click divide by 2 and it'll show answer on the top. 12 is even. I'm going to divide by 2. That gets me 6. 6 is even. I'm going to divide by 2. That leaves me with 3. Okay? So now I have to go through and find my pairs. Here's a pair. Here's a pair. Anything circled is going to reduce down to one of those and go on the outside. So I have 2 times 2. Anything left over is going to go on the inside. So I have 5 times 3. 2 times 2 is 4. 5 times 3 is 15. Okay? Double check myself. Ta-da! Okay. Now, I'm going to try to turn the page. Turn, turn, turn. You do have a check this time, so you're going to try this one out. Remember the difference here. We have an 8, and we have a 14. You can divide things into 8. Okay? Pause the video, try this one. Okay? So let me start with my 8. Get your calculator if you need it. We got 8 on my calculator. It's even, so I'm going to divide by 2. That gives me 4. 4 is even, so I'm going to divide by 2, which gets me 2 and 2. I'm done. Nothing else to divide. Now I'm going to come do my 14. 14 is even. 14. So I'm going to divide by 2. That gets me 7. 7 is not even. We can't do anything with it. Now remember, we're going to take everything into consideration when I'm circling pairs. Okay? There's a pair, so a 2 comes out. There is a pair, so a 2 comes out. That is not a pair. So right now I have 2 times 2 and the square root of 7. Okay? 2 times 2 is 4. Square root of 7. If this part confuses you, you can draw an arrow on the end of that one so that you know that it's going to be the end number. I just realized that that might be confusing, but it's coming after we circle them. Okay? Let's take a look at example 3. That's when we're dividing square roots. So it's the square root of 24 divided by the square root of 3. Well, I'm pretty sure 24 can be divided by 3. 24 divided by 3 is 8. So I'm going to put the square root of 8 here. That's not my answer. That's not my simplified answer. But now I can go factor just 8 instead of trying to factor that, and divide them out. Okay? If I got a decimal here, I'd want to do each one individually. But I didn't get a decimal here, so I'm going to factor out 8. Okay? There's 8. Divide by 2. I got 4. Divide by 2. I got 2. Circle your pairs. There's a pair. So outside, inside. 2 square root of 2. Okay? You could have done the same thing here and then canceled out things that were on the top and bottom, gotten square roots, divided. This was easier. Okay? Example number 4. Now we're going to do square roots with variables. We're going to ignore the variable part for now. Let's do the number and then I'll show you the variable part because it's as easy as circling pairs. Okay? Because we have our square, our 2 on the outside. So I have the number 525. I hope I don't run out of space here when I'm doing my division. I've got 525. It is not an even number. So, but I don't want to jump straight to 5. So I'm going to check on 3 first. Is this divisible by 3? Yes, it is. So 3 is a prime number. When I divide, it gives me 175. Let me check and see. Is 175 divisible by 3? Divide by 3. It is not. Well, 175 divided by 3 gives me a decimal, so I don't want to do that. So now I can jump to 5. Divide by 5. Well, that's possible. So if I divide by 5, I get 35. 35 shouldn't be divisible by 3. Nope. So I'm going to divide by 5. So divide by 5, that gets me 7. Okay, gone with that. Look for any pairs. There should be some. I've got a 5 and a 5 here, which is going to bring 5 on the outside. Let me put my answer down here. 5 on the outside. Oh, I forgot to write my 5 here. And then inside I have 3 times 7. 3 times 7 is 21, so I have 5 to the square root of 21. Okay, but I'm not done. I've got x's. Here's like the picture way, the easy way of doing this. I'm going to take my x to the 4th power, and I'm going to go 1, 2, 3, 4. Okay, circle groups of 2. 1, 2. How many groups of 2 did I have? 1, 2. So I'm going to have x squared. And actually, it's going to get written over here with the 5. I'm just going to make that as there's my notes of everything that I need, and then we'll put it in order. Okay. Now look at my y's. I've got 1, 2, 3, 4, 5 y's. There's one group of 2. There's 2 groups of 2's. So there's going to be a y squared on the outside, and there's going to be a single y on the inside. Let me rewrite this because it's getting hard to see. I'll put our answer up here. So I'm going to leave some space. I've got a 5 on the outside. I've got an x squared on the outside. I've got a y squared on the outside. I had a square root of 21 on the inside, and I had a leftover y on the inside. Now I have to do my z. It's going to be the same thing as the y, right? If you're unsure, you can do it again. 1, 2, 3, 4, 5. Circle groups of 2. 1 group of 2. 2 groups of 2. So that's 1, 2 z's. So z's squared on the outside and 1 z on the inside of the radical. So I started trying to make notes down there. It didn't really work. So here is our answer. Okay. So for these, remember division? It's almost like dividing these by 2. It's kind of crazy. Yeah. Okay. You have a check. So do your number first, and then do your groups of variables. Okay? There you go. Try it on your own. Press pause. I'm going to add my number 147 to the calculator. Let's see, is it divisible by 3? Yes, it is. It gives me 49. I know something about 49. It was in my original example. It's a perfect square. If I didn't know it was a perfect square, I could try, is it divisible by 3? No. Is it divisible by 5? No. Is it divisible by 7? Yes, it is. I get 7 and 7. So now I'm going to look for my groups of 2. Here's a group of 2. So 7 is going to come out. So 7 out. Inside, I'm going to have a 3. Let me do my x's. I've got x, x, x. Circle groups of 2. I have one group of 2, so I'm going to have an x out here. I have one left over, so I'm going to have an x in here. Y, I've got 1, 2, 3, 4. I have 2 groups of 2, so I'm going to have a y squared on the outside and no y on the inside. Z to the 5th. 1, 2, 3, 4, 5. Circle groups of 2. 1, 2. So I'm going to have z squared on the outside and a z left over on the inside. Okay? Word problem time. So they want us to write and solve a radical equation. Sarah uses an online calculator to determine how much interest she would accrue in a savings account after 2 years. She plans to invest $750, and the calculator determines that she could have $780 after 2 years. She can find the interest rate of the savings account by using the formula R equals the square root of A over P all minus 1, where A is the amount after 2 years and P is the initial investment. So pay attention to that. What is the interest rate? I know interest rate can be a percentage, which means I can use a decimal. Yippee! So let's do R equals A is the amount after 2 years. So amount after 2 years, that means 780 is going to go on the top. P is the initial investment, which is 750. And don't forget, this is all under a square root. And then we're going to subtract 1 at the end. Okay? This is one of those times where I'm going to say, use a calculator, use a calculator. This is so easy, use a calculator. Okay? I'm going to cover the problem somewhere. There you go. I'm just going to do 780 divided by 750. What do I get? 780 divided by 750. I get 1.04. So right now I have the square root of 1.04, and then I'm going to subtract 1. Okay, well, that's kind of a weird number. But I'm going to, sorry, motion at my front door. Let's do square root. Let's do 1.04. Okay, I get 1.019. And then I want to subtract 1. Okay, press equal. I'm sorry, I didn't show you that. That's what I got when I put the square root in there. I pressed equal so I can subtract 1 minus 1. And now it's a decimal. I have 0.198. I'm going to leave it there. It's an interest rate, so I'm going to round to the nearest 2 decimal. I didn't even write that number correctly. 0.0198. I'm going to stop there. An interest rate, I'm going to go to 2 decimal places, so I'm going to go right here. The 9 makes the 1 turn into a 2. So I have 0.02, but I need it to be in an interest rate. So interest rate, I'm going to take my 0.02, 0.02, and I'm going to multiply by 100. So I have 2%. My interest rate is going to be 2%. Okay. Simplifying cubed root expressions. A cubed root number is a value that when multiplied by itself twice gives the number. A perfect cube is a rational number with a cube that is an integer. So we're doing 6 times 6 times 6. I don't know why I said twice. It's 3 times. Cube is 3. Okay, so out here, our index is going to be 3. So the biggest thing we're going to change here is when we go to circle after factoring, we're going to circle groups of 3. Okay, so I have the number 343. When I divide, I'm going to look for groups of 3. So 343, it ends in a 3. It should be divisible by 3, right? Wrong. So 343 divided by 5. Nope. 343 divided by 7. There we go. That gets me 49. And then I know that 49 is divisible by 7. And it gets me 7. Okay? But when I'm looking right here, I'm looking for groups of 3. This tells you what groups you're looking for. So I've got a group of 1, 2, 3. So all that comes out is a 7. So the answer is just 7. Okay? Let's try that with a different number. That it's probably not going to be even because that's how they teach us things. I've got 135. 135. It ends in a 5, so it's divisible by 5. That gets me 27. Ooh, I should have started with 3. It's okay. These don't have to be in order. That's how my brain likes to do them. I know that 27 is divisible by 3. It gets me 9. I know that 9 is divisible by 3. And it gets me 3. Well, looky-loo there. Groups of 3. 1, 2, 3. So I'm going to pull out a 3 on the outside. And I'm going to have a 5 left over on the inside of my radical. Okay? I think it's a you try time. Oh, nope, not yet. Example 8 first. We're multiplying cube roots. You do this the exact same way that we multiplied the other ones, except for you're circling groups of 3. So I have a 2. I can't simplify that anymore. That is a prime number. Now I have a 36. So I'm going to simplify out a 36. So 36, it's even, it's divisible by 2. I get 18. 18 is even, it's divisible by 2. I get 9. 9 is not even, but is divisible by 3. And it gives me 3. Now, looking at all of my prime numbers. So the original number, if I factored it, I'd look at their prime numbers. And then these prime numbers, circling groups of 3. So I have 1, 2, 3. So that's going to bring out a 2. What's left over? I've got 2 3s, but it's not a group of 3. So they're going to go back inside the radical. So here I have 2 on the outside and 3 times 3 times 3 on the inside. Remember, there's a little 3 in there. You're like, oh, 3 times 3 is 9. That's a square root. No, this is a cubed root. So I've got 2 on the outside and the cubed root of 3 times 3 is 9 on the inside. This is your answer. You got to have that index there. Otherwise, it means something completely different. Okay? I think you get to try it. Oh, I'm still wrong. They're not going to make you try it until the very end. We're going to divide cube roots, okay? So let's see. Can I divide these evenly? Let's look. Can I do, clear, 896 divided by 16? Yep, I get 56. Okay, so now this is, to simplify it a little bit, the cube root of 56. Now I can take this 56 and factor it. Okay, so I have 56 on my calculator. It's divisible by 2. I get 28. 28 is still even, so it's divisible by 2. I get 14. 14 is still even, so it's divisible by 2. I get 7. Look for groups of 3. 1, 2, 3 2s. Means I bring out a 2. It's going to be on the outside. And the 7 is going to be on the inside, but don't forget to write your 3 as the index. Okay? Example 10. I guess we're out of checks. There aren't any more checks on here unless I just missed them when I was, I'm going to try not to end the recording and look at my screen here. Oh no. Okay, we're still good. I'm not going to touch anything. We're just going to do this one. And then I'll see if I missed something, okay? So this is just like division, right? I'm just going to do, this is going to be easier just to do one and then the other. And I'm going to put the answers on the top, okay? So let's first factor out 15, okay? Hopefully you can do this one without a calculator. But I've got 15 is divisible by 3, which leaves me with 5. Well, that doesn't do much. There's no groups of 3. So over here, I'm going to make a big, long fraction bar. I'm going to put my 3 times 5. This is going to look crazy for those of you that are really good at math, but I promise like it's going to help those of us that aren't. Okay? 81. Let's factor 81. 81 is not divisible by 2. Is it divisible by 3? Yes, it is. Now that's 27. Is 27 divisible by 3? Divide by 3. That is 9. We know that 9 is divisible by 3, and it gives us the answer of 3. Okay, so here's kind of where the craziness is here. I can pull out a group of 3. It's going to come out on the outside And all of this is going to go back in square root. This 3 is going to go back in the square root. This is still in the square root. I probably should have made a line for those that are in and those that are out of the square root. Okay? So in the square root, out of the square root, because I pulled out a 3 because it's a cubed root. Okay? Now, let's look at my x's here. So if I'm looking at it, I've got 1, 2, and 1, 2, 3, 4, 5. Okay? I'm actually going to cancel 2 of them out first because I don't need them, right? And then I'm left with 3 on the bottom, so I can circle that and bring an x out of the radical. See how I did that? The y's, there's no y's on the bottom, but I have 1, 2, 3 y's on top. I can circle that group and bring it out of the radical. Now I have z's on top. 1, 2, 3, 4. I can circle 3 of them, bring a z on the outside, and leave 1 z on the inside. Let me double check myself. Example 10. Yep, we're doing good. One more thing that I want to show you. So now we can still cancel things out when they're in here, right? So I have a 3 in the radical and a 3 in the radical, but they're on top of each other for division. So this 3 in the radical on top is going to cancel out this 3 in the radical on the bottom. So now what am I left with? See how I kind of had to map everything out? I'm left with y, z, and then I have a cubed root. Remember that has a 3 there. There's a 5z left there. But that's just the top. On the bottom, I have, excuse me, I'm so sorry, 3x. Okay, so I had to figure these out and put them, and then I had to cancel even more out to get my final answer. Okay, and they didn't give us lots of checks, so that means you're going to have lots of practice questions when I come to your table. Woo! If you missed anything, go back and take notes. I think this is a fairly easy lesson. Bye!